The second question of CodeForces round 923 division 3 is following the string. Okay. Now in this question, you'll be given a string s of length n, and there is something defined as a trace of a string, which is basically an array A of n integers, where every value in the array is basically the number of such number of indices j less than a of less than I, such that s of I equals to s of j. Okay. Now it might sound confusing, but it's very simple. Okay. Basically, the string is of size n, right? And the array is also of the size n. Now, what will each element in the array hold? Basically, whatever the character is present at that ith index, basically, in a way, you can say it's the frequency of the character present at the previous index. Okay. So, let's say this is the string. Okay. Now, in this string, here A has occurred one time, right? But before this point, A has occurred 0 times, right? So we just simply put 0. Okay. Now we came to B. Here B has also occurred. B has occurred for the first time here. So again 0 here, right? Here R. Okay, let me zoom in. Here R has also occurred 0 times, right? Here A. Now you get 1 because before this index, A has occurred once before. Okay, so that's what this value really holds. Okay. Anyways, we'll discuss that in the solution as well. But yeah, basically you're given the trace of the string, and what we need to do is we need to find any string that can be obtained from this trace. And they have also mentioned that the string will only consist characters from A to Z, that is lowercase Latin letters. Okay. And let's see one of the test cases here. So here there is this test case where we have 8 and 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, right? So in this, basically it means that this string has occurred once before, this string has occurred twice before, which means all the characters have to be equal, right? All of them have to be equal, only then this will satisfy, right? Now here, in the sample cases, it's A, but any other character would also have been a valid answer. So that's one of the things. Basically, multiple answers can also exist for a test case. Okay. And the number of test cases here can be up to 10 power 4. The n value is up to 2 into 10 power 5, and a of I value is in the range 0 to n minus 1. Okay. So yeah. Also, the sum of n over all test cases does not exceed 2 into 10 power 5. So yeah, this is also one important condition to keep in mind. So yeah, let's see how we can solve this question. So here in this question, we can solve it with the help of a case. So let's say this is the trace of the trace given to us in the question. So this array, entire array, is basically the trace given to us. Okay, and we'll try to fill in this string. Okay, now I've allocated n number of blocks in this string, and I'll fill these blocks according to a valid solution that can exist. Okay. Now, what we can do here is we can fill all the blocks in this character by character, right? So, what do I mean by that? I mean that I'll fill only one character at a time. Basically, if I have a character A, I'll just fill all the places where A should occur, and then I'll fill all the places where B should occur, or then C should occur, and so on and so forth, right? So, what I'll do in that case is, now here I come to the very first index. I see, okay, there is 0 here, right? So I'll just simply allocate A here. Okay. Now I'll keep going ahead and I'll try to find an index where I'll get 1. Okay. Basically, I'll get 1 here. So it's possible to put A here because we have already gotten an A before here, right? Before this index, right? So that's why we can put A at a 1 here. Now after this point, only after this point, we'll try to find a 2. Okay. And a 2 is right here, right? So we'll put a A here, right? Now after this, I'll find a 3, which is here. So I'll put a A here. And then there is a 4, which is at this point, and then we can put an A here, right? Now this will always satisfy the conditions because when you come to 4, there are already 4 A's filled previously, right? So that's why it will always satisfy. And now we'll start filling B, right? And we'll start filling B in all the places where the string is not filled yet. Okay. Now, to keep track of this, we can basically declare a string with a random character that is not in the sequence of A to Z. So let's take some character like 0 or any other character like 1. Okay, let's say. Okay. So you can just take any character or you can just take a dot. Okay. Just take a string uh, of size n and fill it with dots. Okay. And with that, it will help you to keep track of which indices are not filled. Okay. Now you can do the same thing with B, right? So first B here, then where do you get one here? Then you get one here, right? So that's it. You stop there. Okay. Right. 0 and then 1. Now for C, you get one C here and then one C here. Okay. Now for D, we'll get 0 here and there is no 1 at all. So that's it. And for E, we'll get one E here. Okay. So that is how we fill. So basically for every character, we go through the entire string, right? So that's why the time complexity for this approach will be O of 26 into n. Okay. Because for every single character, we are going through the entire string again, right? So that will be the time complexity. And space complexity will be simply O of n. Okay. Because we are just filling up one string, right? Now, this approach this question can be solved in multiple ways, but I found this to be, a most simple way. And this approach will not use maps or sets, but using maps and sets, the question can become simpler. You can solve it in a simpler way. But for the people who are not comfortable with maps and sets, this approach will work best. Okay. So this approach and 26 into n is a solution that will get accepted because as we saw in the constraints, n can be up to 2 into 10 power 5, right? So if you do 26 into 2 into 10 power 5, even in the worst case scenario, you'll get some value around 10 power 7, and even that will get accepted, right? So yeah, that is how we solve the question.